Hi everyone. Today we are going to have a lesson in goniometry. So this is one of them. This is a goniometer. It is used to measure range of motion on the various joints. This particular one is a 12-inch goniometer. It's the standard goniometer. We can use this on shoulders and knees and some of the bigger body parts and stuff. So aside from things like positioning your patient correctly, where you can get the most accurate reading and get the position of the joint correct so that you're actually measuring its full range of motion rather than having it limited by the length of the muscle or restriction by a muscle. So we're going to go through the chart that you have. It's posted in Blackboard with the various joints and what the norms are for those joints. We're going to go through them one by one. But for right now, I want you to just look at your goniometer. So if you'll pull out the 12-inch, the standard one of the things that you're going to see is that it has a bunch of numbers on it. This is just a glorified protractor, if you remember that from school, from math class. And what you're going to see is there are a bunch of numbers on here. On this particular one, there is a set of black numbers and a set of red numbers. So before we even start looking at those numbers and what direction they go in, there's numbers that go all the way around and numbers that don't go all the way around, zeros that start at different places. Let's look at the tool itself. This tool has a movable part and it has a stationary part. We call the part that is attached to the dial with all the numbers on it, this arm here is called the stationary arm. It is the one attached to the dial. And then you have this arm. This arm is called the movable arm. It's the one that's moving. You will also see in different books that this may be called a distal arm, and this one may be called a proximal arm. Easiest to remember that this is the stationary arm and this is the movable arm. Once you do that, you will look and see that there is a very center point here where everything pivots around. That is called the fulcrum, F-U-L-C-R-U-M. So that fulcrum is going to go at the center point of the joint, literally where a joint is moving at that point. That's where we're going to position that. If you look at it now and you look at these various numbers, as I'm going to try to get in close here to show you, this particular one here, if I do it this way, can you see that there's a 0 here on these black numbers? Well, if you were to follow that, they're orderly. So 0, and then 10, 20, 30, 40, and you can assume that the one in between is a 5. So 0, 5, 10, 15, 20, 25, 30, etc. And this one will go all the way around, all the way. So it'll stop here at 180. And then these numbers keep going all the way around. But if you notice, the numbers here actually get backwards. Let me flip this so you can see it better. So here was my 0, and then it went all the way around to 180, and then it changed. It went back down 170. If I wanted to measure something and go all the way around, I would just switch from the black. Now, if you look at the red numbers, you see how now they go from 180 and then 190, 200, 220, etc. So what you want to do is, let's just look at this in a very basic way. And that very basic way is, if I was to align this, right now you don't need to worry about what you're going to align it to. When we align this and our starting point is 0 here, okay, if I was to then follow the line, do you see this nice little black line going here? If you were to follow that, starts at 0, right? And you were to keep going, and let's say I was to stop here. What number would you choose for that angle? And when I'm talking about the angle is, we started here at 0. Here's the fulcrum. So here's the number where we started, and here's the number where I stopped. So if I started at 0 and I followed it up, what number would that be on the black numbers? 50, correct. So this motion, this patient, for this motion, they got 50 degrees of motion. So from 0 to there was 50 degrees. If this person started here and I was able to measure the joint all the way up to here, how many degrees of motion do they have now? 160, correct, okay? What if we started here all the way back down and they moved and they started at 0 and we followed that black line? I'm following this line right here, this line right here. And we kept going and kept going and kept going, but they went all the way to here. Now what number is it? Okay. So now you actually have to choose what that number is going to be. So if they started here and kept going all the way around, what number would you choose? It wouldn't be the number here. See where my dial came all the way around? And we passed the 180. And we kept going and I went all the way to here, right? So what number would you say that is? Well, that 70 wouldn't make sense, right? Because we moved a lot more than 70 degrees. Well, what other number would it be? Well, it's nothing here because it's not matching up to anything. What about this here? What number would that be? Would it be 110? Problem is, we know that we went at least 180, correct? We went 0, 10, 20, 30, 40, 50, 60, and we all the way up here, and that was 180, and then we kept going. So 110 wouldn't make sense because that's less than 180. So then what number are you going to choose? So in that case, you are now going to switch to the red because the number is going to be bigger than 180, and that number is now 250 degrees. Now, nobody really has 250 degrees of motion in a normal joint. A gymnast might, or ballerina in some joint, but not the normal joint, okay? So here, this is just to give you an example on how to teach you. So it is very possible, though, that someone has 180 degrees of motion. So shoulders and things like that, they would go all the way up, and look there. It went all the way up, and now I see a 0. Uh-oh, I went from 0 to 0. Well, what's a number that's going to be bigger? But I moved that motion. Look down here, 180, okay? So that was 180 degrees. What about the person that is able to move a little bit more than that? So they started here, and they came all the way up to here. What would you call that? Would we call that 20 degrees? No, they moved a lot more than 20. They started here and came all the way up. So now you would actually flip to bigger numbers. And see this here, that red one? It says 200. And that's the number of degrees that person moves. So the goniometer is something that you need to play with. You need to get used to it. When you get good at this, you're not going to care if you're reading the numbers backwards, upside down, if this is the motion, this is the movable arm or the stationary arm. It won't matter when you get used to this and as a clinician. But for now, you need to learn how to read this. And the best way to do it is just hold this goniometer in front of you and look at it all lined up. It's at 0. And then just move this thing. And say, okay, how many degrees did this move? Okay, well, it says 70, but it also says 20, and it also says 290. Well, you've got to let your common sense, everyday stuff kick in and say, okay, how much did I move? Well, I certainly didn't move more than 180 degrees, so my number can't be the 290. Did I move 70 degrees? Or did I move 20 degrees? Well, 20 degrees would have been from here to here. That's it. This would have been 20. And that's not what you did. You moved to here. So which of these numbers would you choose? The 70. Correct. So another way to think this in your head, so if you have a moment of panic and you can't decide which number to pick, is pick the thing that you do know. So if I was to tell you I was to ask you, what is a right angle? Would you show me this? Right? Remember this? That's a right angle in here? it's 90 degrees, correct? Anything that's less than this, anything that starts here, but now I move it, and let's say I only moved it this much. Would you call that number something bigger than 90 or something smaller than 90? It's an acute angle, right? So it would be something less than 90, right? You can take wild guesses to give you a ballpark figure. This line that I drew for you right now is about half of this. So you know that this was going to be somewhere around 45 degrees, okay? This particular one, if I was to measure it, probably would be about 45 degrees. But you would have to measure it exactly. All right, let's mess around. So if I was to place this here, and I was to move my goniometer, let's flip it around, and I was to put this on the fulcrum, which would be this point, and then I was to move this little arm here, and let's see how many degrees we got. And we actually moved, that was pretty darn close. Okay, we moved 43 degrees, all right? So this is 43 degrees. I'll change it, 43. Okay. But now, what if we moved this line, and I was to move the goniometer, or I was to draw a line for you that came out to here. Now, how many degrees is that? Is that less than 90, or is that more than 90? Do you see where I'm going with this? So you can have a checkpoint for yourself to understand if a movement is occurring for less than 90 degrees or more than 90 degrees. And then you would measure this. And in this case, here's my baseline. And so a fulcrum will go here. And I were to move this. Oops, let's flip it around so you can see it. Here, here's 0, follow it. 10, 20, 30, 40, 50, 60, 70, 80, 90. And now that looks like 120 degrees. So this angle is 120 degrees. So does that make sense to everyone? So 90 is your right angle that you are used to seeing, okay? Half of that would be about 45 degrees. So if something is less, that angle is less than 45, you know that that number can't be greater than 45. If it moves more than 45, but less than 90, or what if it moves more than 90 degrees, and then you know that that number's got to be higher than 90, and then potentially greater than that. So look at your goniometer, mess with the numbers, look at the black and red numbers. Know that the black numbers will start here, and then they go 10, 20, 30, and they go all the way up to 80. But they don't, the black numbers don't keep getting bigger if I was to keep going. They shift gears to the red numbers, and I can follow those if I need an angle that's bigger than 180 degrees. I can also use my red numbers when they shift, but I can also use my red numbers if my point of start or my starting point is here. Something that you'll learn when we get to the different joints. If my joint starts here, for example, the ankle dorsiflexion, do you see how they created a 0 there for us? So now I can just start counting. So if my person moves their foot, and I'm going to flip it around for you this way. Can you all see that? Is it backwards? It's good. So if I'm here, let's just say this is their leg, and now I ask them to move their foot. See how nice that is at 0? And then if I go to there, that's 20. So they've moved 20 degrees. And if I'm going to do, that was dorsiflexion-ish, and if they're going to move a little bit in the other direction, it would be the other way. So your red numbers give you that right angle starting point. Again, not anything that gives you a lot of reference right now, but as we get into the different joints, you'll be able to understand. So this is a 12-inch, a full round dial goniometer. And then you have this little guy. This is a half goniometer. This one is really great for things like fingers and different joints where you needed to clear the table. You don't want it to hit the table. So we would use that. You can use this on angles. The difference is if you look at it real closely, see the numbers, how they only do half a circle. So they only go to 180, okay? And they only go to 180 in the black, and they only go to 180 in the red. But that still gives you that point of reference. The difference is if my number goes beyond the 180, I have to do a little bit of math. I just have to add. So it would be 180 plus that, 180 plus that 40, okay? Now, what if and it's flexible. That's the other thing. This one's nice and bendy, so it conforms to different areas, where this one's not very flexible. It's pretty stiff, right? So there's another goniometer as well that is a full circle. It's small like this, and it looks a lot more like this one, but it's small, it's flexible. We use it for smaller areas. And the other thing is, it's the accuracy of the numbers. On this goniometer, each of those little marks, each of them is 1 degree. So if I was to start here and show you, okay, see my 0? There's 0 and there's 10. So each one of those increments is 1 degree. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When you use a goniometer like this one, this particular one, the 0 to 10, can you see it there? Each one of those tiny things is 1 degree. So it's 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are other goniometers that don't have it here. Other goniometers where each of those increments are worth 2 degrees. So you have to be attentive to that so that you're accurate with your numbers. Okay, some of them are only in 5s. So just be aware of that you do it accurately. These goniometers come with this nice little ruler on it, centimeters and inches. You can use it in a more extended way. The same thing with the 12-inch. There's a ruler here in centimeters and inches as well. So get used to the goniometer, get used to how it works. We're going to be using this quite a bit. And the more familiar with it you are, the more comfortable you are, the more accurate and quicker your range of motion assessments will be, and you won't have to make your patient uncomfortable or take a long time to do each one. So I hope this was a good, valuable lesson to you. Please be ready with the goniometer so that when we actually get to class and get measuring, this is already a lesson that you have and you understand well, and you're not trying to fumble through that in class and trying to learn range of motion. Hope you guys have a good one. Take care. Bye-bye.